Bismillahirrahmanirrahim. Welcome to the fifth lecture of multimedia technology and application. So this lecture you can be found it in a data communication networking book by Behruz Frozen and the fourth edition. So in a data communication networking book, this chapter is so simple and so easy. So that's why I selected to choose this topic from the Behruz Frozen book. So today we are going to be study about real-time interactive audio video concept. So what happen in a real time when you are sending an audio message or when you are sending a video message? So in real time interactive audio video, so in a real time interactive audio video, people communicate with one another in a real time. So what does it mean? It means that you are texting to each other, you are calling to each other, you can make a video conference call, you can make a conference call, you can talk by voice over IP and so on. So it means that you have a network. So through a network you are communicating with each other. So when you are communicating through a network, so these interaction or data communication is called real time. So how this real time can works or can happen to make communication, so we will see later on. So the internet, phone, or we can say it voice over IP is an example of this type of application. Video conferencing is another example that allows people to communicate visually or orally. So that's just as a kind brief of explanation about real time. So now what we can study regarding real time, so we will be study about the characteristics, how this interaction can happen in a real time. So first of all, this just like a think about ideal case. So the first is time relationship. So what does it mean now? Time relationship mean that you have a sender and you have a receiver, and between a sender and a receiver you have a network. So sender can send their data through a network to receiver, or a receiver can receive the data through the network. Okay, so in a time relationship means here we have a client and we have a server. So client want to access the server, and then when client access the server, so server will send a specific or desired data or information which client needs. Okay, it's a one kind of example. Another example can be happen that like multicasting or a broadcasting, like television wants to broadcast or multicast the channel or the drama serial or the videos to entire country. So in that sense, server will always send the data. Client just wants to watch the data, client just will receive the data, but server will always be send the data. So it means the flow of information will always from server to client. So coming to now, you understand this concept. So now server sending a data from second 0 to second 10. Okay, so when server send a data like time is starting now, it can be 0.0001 millisecond. So it's starting. So when it's starting, so the client will receive a data with next second, like 1 second, because it's starting to send the data and it will receive the data. So when the sending and receiving, there will be a milli or microsecond delay, because sender or a server sending a data, so they can make a data first, then it will send. So when it's going to be sent through a transmission medium, or it can be sent through internet, or it can be sent through a network, so it takes a bit time. So that's why we are saying that server will send a data from 0 to 10 seconds, then the client will receive the data from second 1 to 11. okay, because it will sending a data. When it will sending a data, then it will received. So that's why starting from 0 to 1 and 10 to 11. So just a difference of 1 second. But it just think about it, it's just an ideal case. It's not, we are just giving you a concept how the data will send. Later on I will tell you the actual or the real scenario of sending a data. Okay, so from 0 to 10 second, so it will receive from 1 to 11 the first packet, then second packet start from 10 to 20, so it will start from 11 here, so it will be 12. It start from 11 to 20, so it will start from 12. It's end with 20, so it end with 21. Then it will 22. It will 22, so it will be start from 23, 30 to 31. So basically the concept behind this scenario is that the flow of a data is always from server to client, one thing, and the second important thing is that when the server sending a data, so there will be a bit difference of time. It's a just ideal case now. So later on in the next slide we will see the real scenario, what can happen when you are going to send a data from a server to client, or you are sending a data from sender to receiver. Both concepts are the same, but just I'm just telling about the server because server always sending a data, okay. But one thing if you can see that sending a data taking a 30 seconds, receiving a data taking a 30 seconds. So sending a time same 30 seconds, arrival time and a play time both are 30 seconds same, okay. So this is an ideal case, keep in mind. So now coming to the real case, because whenever you are going to send a data from one point to another point, so there will be a delay of when you are sending a data from point A to point B, so there will be a delay in the time because receiving a data maybe take a time. How it can, so we have a two different kind of concept here. So the first concept is jitter. What is jitter? So jitter is introduced in a real time data by delay between a packets. What does it mean? Let's, whenever you have a noise in a medium, so noise can disturb your signal, disturb your data, and we have a different kind of jitter, random jitter, systematic jitter. So random jitter can happen through a transmission medium by electron or by a noise, and systematic jitter can be happen through a system, through a devices. So jitter mean that the delay between the packets. So what does it mean now again? So let's you are sending a data from 0 to 10, okay, this is your send time, okay. So when your send time is 0 to 10 and your receive time is start from 1 to, now you don't have a, so it means, let's see, we can say this one, we say that 11, we say that it's a 11, okay. So it's 11, so it need to start from 12, okay, it start from 12. This is the first packet is accurate. Now the second packet which start from 12, it need to be received in a 13, but not, here is a 15. So this difference in a time is called jitter. So what is jitter? The difference of a time when packets sent from a server to client, or when a packet sent from a server from a sender to receiver. Again, if you can see here, again 20 to 30, again there is a difference of a time. So this is called jitter. So how, because jitter is not good for our communication, so we need to reduce the jitter, or we need to be remove the jitter. So jitter will always be occurring in the communication, so we can try to reduce the jitter. How it can? So the first concept about to reducing a jitter is timestamp. So one thing again, you can see the time is a 30 second here, and here is more than 30 seconds. So it means there is a delay of a time now. So one thing more, that whenever you have arrive the data, and play time. So in this concept, or in an ideal case, we can take both of them together. So arrival time and play time both are the same. So like you can receive the data, then at the same time it will be play. So this can happen a jitter. So when we want to reduce the jitter, so we will separate the arrival time and we will separate the play time. So we will see now how it can. So now coming to timestamp. So if you can see jitter definition, the jitter is short term timing variation from its ideal position. Ideal position was the above one, this one was the ideal. So this is your actual now, which have a jitter. So jitter is called variation in a time. So the first thing we need to do is timestamp. So what can do? The same diagram is here, 0 to 10, 1 to 15, 10 to 20, 15 to 27, and so on. Okay, same direction of data flow. So what we can do in a timestamp, we just separate the arrival time and we separate the play time. Just you can separate both of them, because when you arrive, when you receive the data, then after receiving you will play the data, you will play the movie, you will play the audio, you will play the video. So this concept is applying in everywhere now. So if you can see like 0 to 10, so 0 to 10 is starting to 10, so wants to be like 1 to 11, so it will be 1 to 11. So when 1 to 11, so he now saying that start from 1 or 2 3, he said it start from 8, because from 0 to 7 you are receiving information, and this information is going to store temporary in a buffer. So from a buffer you just pick your information and you can hear it, you can watch it, you can read it, and so on. So that's why from 8 to 18, then here was a 15, so it start from 18 now, because storing a data, to 28, so it was 27, then it's again 28, it is 37, it's 38 now. So the play time and arrival time is not same. First of all, play time and arrival time is going to be separate, because we need to reduce the jitter. So reducing a jitter, the one of the best option, you need to be take a timestamp between arrival time and play time. So to prevent a jitter, we can timestamp the packets and separate the arrive time from the playback time. Okay, so it's so simple. So this is the actual scenario behind you are watching a movie or you are talking with someone. So just taking a bit time, So now coming to a buffer position, I mentioned before that we have a buffer where we can store the data for a temporary time. So again the same is to prevent a jitter, we can timestamp the packet and separate the arrive time from the playback time. So playback buffer is like you are saying that your time you are receiving your arrival time from 1 to 7, just taking 7, but your play time is starting from 8, from second 8. Okay, it's stored in a buffer, it's your buffer, your data is stored in a buffer. So now you can watch it, you can read it, you can listen, you can talk, whatever. Okay, so this is a buffer position. Again come to this one, like you have to be your time, like if you see the difference in the time in this one, from 15 to 18 it was a 3, so your buffer is like in a 3, then start from 18, and the position here was 15 seconds. So after 18 will start, because the data is arrival time and the play time both will be not be the same here. So the playback time and the arrive time is going to be separate now. And again the 28 to the, like it was 27, and so start from 28, and the last one was is 38. So again the same is, the difference was 1, 27 and 28 difference was 1. Here 15 was in a server side and 18 was a client side, so the difference was 3. So here it was, the difference is 7, because 7 was 1 to 10 and then 15, so 8 to 15 it was, the difference is 7. So the 7, 3 and 1, it's a difference between the timing. So when there's a difference, it means that your arrival timing and your play time is different now. Okay, so this is the actual scenario behind your communication. So we have some concept behind it. So a playback buffer is required for real-time traffic. So it means playback buffer is always be required for it. A sequence number on each packet is required for a real-time traffic. Sequence number of packets, you know about networking. So the packet is always be sent in a sequence. Like you are talking that hello, how are you? So hello, how are you, it will be sent like hello. First we will send a hello, then hi, how are you, like this in this end. So your packet need to be in a sequence. For real time it need to be in a sequence like 1 2 3 4 5 6 7 8 9 10. It not to be 8 5 4 3, like not be like that. So a sequence number on each packet is required for real time traffic. Okay, so one thing more, when we are watching a movie or especially when we are watching a movie or drama serial on a television, so one thing keep in mind that drama serial is not going to be retransmitted. When if let's see you are watching a drama serial, at some extent your signal is going to be disturbed and you are not be seeing the clear graphics. So it means your signal is disturbed, but this signal is not going to be retransmitted from your server. Okay, so keep in mind this thing. So in this scenario, in the broadcast from server to client, so we need to be take it arrival time and arrival time and a playback time to be separate, because it's so sensitive case. Because whenever when you lost the signal, you lost the movie or you lost the graphics or you lost the image. Okay, so that's why that sense of packet number need to be in a sequence, need to be a separate real time, in a real time need to be separate arrival time and playback time and so on. So real time traffic need the support of multicasting. So real time traffic need the support of multicasting. You know about a multicasting, like you have 1 2 3 4 5 client and server want to transmit the data. So 1 2 3 or 4 of the client will receive and one of will not be received. This is called multicasting. If all of them are receiving the signal, it means that's called broadcasting. So one thing which is more important for us, translation. So translation mean changing the encoding of a payload to a lower quality to match the bandwidth of the receiving network. So this is the basic definition of a translation, why we use translation. Okay, hope you guys got the concept. So some another concept behind it, like mixing. Mixing mean mixing in a telecommunication. So mixing mean combining several stream of traffic into one stream. So this is called mixing. Stream, you know about live streaming. So streaming means a signal is coming from a satellite, signal coming from the dishes, microwave dishes, signal is coming from something like from every kind of antenna. So when number of stream is going to be combined into one stream, this is called mixing. So I mentioned before one thing, again we are studying here again. So TCP. So TCP with all its sophistication is not suitable for interactive multimedia traffic, because we cannot allow retransmission of a packet. I mentioned it before. So the same concept is you guys can be read here. So now UDP. So UDP is more suitable than TCP for interactive traffic. So it means for interactive traffic we are using UDP. However, we need the service of RTP. So you guys study about RTP, real-time protocol, in a lecture 2, RTP or TCP, real-time control protocol and real-time protocol. So same concept is here, applying here. And RTP, another transport layer protocol to make up for the deficiency of UDP. So for UDP protocol we need to use RTP protocol, RTP and RTCP protocol. So this was the actual scenario behind the communication, or behind watching a movie, or behind watching the drama series through television. So how it can work. So you guys study that the jitter can happen, how you can reduce the jitter. So one thing keep in mind, this jitter is also occurring, also happen in your telecommunication, your communication as well, in the networking, in your GSM and so on. So just keep in mind the concept of a jitter. So anywhere you are going to watch, you're going to be see the jitter, so the same concept will be apply here. So thank you for your time. See you in the next lecture.